And in this last example, we will compare three methods and the exact solution together. Our function is e to the minus x sine 3x. So the derivative of the function, you can take the derivative by using the product rule. Derivative of the first one times the second plus the first one times the derivative of the second. That's why 3 cosine 3x is coming. So this is the derivative of our function. And I defined the x data from 0 to 4. We divided 0 to 4 into 101 pieces. Linspace command, if you remember that. And I will plug in these x values inside our function, and I will find my y values, or f values, you can say that. And our h is, since again the increments are all same, x2 minus x1. You can take x3 minus x2, x5 minus x4, it doesn't matter, because these are going to be all same result. And we can plot this one, x comma derivative of function, and this is the exact solution. This is the exact solution, exact derivative, I can say that. Let me copy paste this part just to show you. Here you go. CLC. I copy paste that part, and in this part, oops, let me delete the previous one. Run. I run all of it. I don't want to run all of it, but if you run all of it, this is what you will get. But in that one, I just want to run this part. Let me clear the figure and Control V. Couldn't show that part. Here you go. This is the exact solution, exact derivative of e to the minus x cosine x, right? We can find that. And now look at that. Let me open the central difference formula here. So for the central difference formula, we said that x should be starting from the second data until the n minus 1 data, the one before from the last one. So it needs to start from the second data until the n minus 1. Why? Because you know that for the central difference, we are using the next data minus the previous data over 2h increment, right? That's why we cannot use the first data because there is no previous one. And we cannot use the last one because there is no next one. So for the central difference, we need to use all the middle points, okay? That's why in here you can see that this is starting from, let me open these together. This is starting from 2 and it will go until n minus 1. And for the second point derivative, which one we are using? We are using the third one minus first one, right? Exactly, third one minus first one. We are starting from third one minus first one over 2h, right? And it will go for all of it like that. For the fourth one, it will be fifth one minus third one. For the sixth one, seventh one minus fifth one. And until n minus 1, which will be until n minus 1. So n minus 1 derivative will be n minus n minus 2 over 2h. This is how we define the central difference. But for the forward difference, we can find the derivative of the first one by using the next one minus the itself. So the derivative of the first one is f of 2 minus f of 1 over h. And then it will increment 1. The derivative of the second one will be again increment 1 for each. 3 minus 2 over h. Until it will go to the derivative of the previous data. Then the last one. You can see that, and this will be n minus 1 over h. For the backward difference, this time we cannot find the derivative of the first one. That's why we are starting from 2. We can find the derivative of the second data by using the previous one. But it will go until the end because we can still using the n minus 1 data. So n minus 1 over h is going to give the backward difference for the last data. And now you can plot all of it, the derivative, the exact solution, central solution, forward solution, and if you go down, backward solution, all of it is there. I added the legends That's why once we run that, here you go. Let me open that in a big picture. You can see that this blue one is starting at the beginning, which is the exact solution. Exact solution and central solution is kind of, behaving together. And backward and forward has a little bit error that you can find by taking the difference from the exact solution.